Now let's see how we can write our simulation information onto our hard drive for later rendering, because we actually do not need to write our simulation information into hard drive. If you have enough RAM, you can use this. For example, here as you can see, we have all of our cache stored in my RAM. In here, I can just create null at the end, and this null node, this node will just not do anything. It's just therefore we can reference it somewhere else. So we need to just connect this, and in here I'm going to just call this one out, and for render rename this null. And if I were to import this into Solaris, I know that I just need to reference my this out node to better find which node I want to render. It's just there, null. It has no parameter, it just won't do anything. It's just for the reference purpose. Which means I can just go into my lob context, I can go into my stage context by going in here, or it will just change your viewport to the Solaris context. Let me go into the object, onto the geometry level, or if I want to, I can create a LobNet in here, lob network, and I can dive inside, and now we are in the Solaris context. And in here I can just say SOP import, and in here I can just reference my out render node, out render that we have created. Let it accept, and here as you can see our smoke has been imported in here. Now I can just create materials and render my overall simulation. But as you know, we later, when we are going to add more detail, let's say, let me increase the resolution of my pyro solver. So let's go into the setup tab, and in here I'm going to lower down the voxel size to a value of 0.01, and let's hit play. And here as you can see, right now it's taking longer to calculate because we are working with a lot more voxels and we have a lot more high-res simulation. And you will see that our cache size will get bigger, and we will fill out our entire system RAM very quickly, and our RAM may not be enough to store all of our cache. And later we are going to apply material, and that they will also going to be stored in RAM, so it will just create problems. So it's easier to just write your simulation into hard drive and read your simulation information back to avoid filling out unnecessarily your system RAM. So for that purpose, we need to write our simulation information onto our hard drive. First, let me go into the pyro solver, and for this time, for the faster feedback and for the faster working, I'm not going to create that much high resolution simulation. I'm going to just change this to value of 0.05, or maybe let's lower this into 0.03 and hit play. And I think that is enough. This resolution is enough for our purpose. And let's go into maybe the shape tab, and let's add some of the turbulence value in here. I'm going to just lower down its turbulence value, and let's collapse this. And in here, as you can see, we are adding the turbulence onto our temperature. And if you want to add the turbulence into your smoke, you can just change the field. But right now, here as you can see, the temperature field is because present. Let's go into the sourcing and middle mouse button, and let me view this again. And here as you can see, we are creating our temperature volume. Our temperature field is present, and that is why we are getting our turbulence effect. So we can just keep this onto the shape tab, just keep this temperature field, and I can just lower down the swirl size to create a high frequency noise. I'm going to just lower this down to maybe a value of 0.5, and let's hit play. And that will just create a noised up smoke simulation. And down here, let me stop this. Let me collapse this one, and let's also enable the disturbance to break up our simulation even more. And right now here you can see there is too much breakup going on. Our overall simulation is breaking. So I'm going to just lower this value down to a value of 5, a bit more manageable value. And to actually pick up more of our these noise information, as you know, we need to increase the voxel size, but I think this value right now is fine for our this sample project. And let's say that I am happy with our simulation. Now I can just go into the output node, and in here I can define which of these fields I want to import from DOPS. And right now we are importing all of these fields. And if I were to middle mouse button, and here as you can see we are importing 6 grid volume, density, and all of our volume. And because right now we are working with smoke, we actually do not need to import the flame or temperature. So to not import them, let's uncheck this option, and let's also uncheck the flame and also the CD, because we do not have any CD. And let's uncheck this. And now if I were to middle mouse button, and here as you can see we are only importing the density and we are importing the velocity. Velocity is essential for creating the motion blur. Later when you are going to add the motion blur, so you must need the velocity. And here you can see because it is a Houdini native volume, we have separate components, separate volume for the velocity X and another volume for velocity Y and another volume for velocity Z. So let's convert this into VDB, and let's also use the 16-bit float because we do not need the 32-bit precision. We're not working with simulation. We are just going to render this, so 16-bit float is enough. Let's press and hold the middle mouse button, and now we are down to 2 VDB volumes. The density, and it's still saying temperature. We need to just refresh this, view this again, and press and hold the middle mouse button, and now this our inspection window has been updated. And now we are down to 2 volume, density, and well mean the velocity, and it is an a vector volume. And here I can see vector 3, it has 3 values, and density is in a float volume, and VDB supports vector volume, which means we do not need to create separate volume for the X and Y and Z. We can just use a one vector volume to store our velocity information, and that is why VDBs are more efficient. VDBs are awesome. Now let's write out our simulation into our hard drive. We are ready to write. And to write this, let me make this, drag this LobNet in here. And in here, we need to create a file cache node. So let's type file cache, and here we have it. Let's connect this and make sure that it is connected, and it is connected. Let's go into the file cache, and I'm going to bring up the parameter of this node. And first we need to define the base name, and onto the base name we have some expression going on. First we have the $hip name. The $hip name your current project file name. If you have saved your scene file, and let's say you rename this one to SmokeSim, it will just use your project file name and add in here. That's what the $hip name expression is. And we are adding the dot. After that we are adding another expression, $OS. $OS mean the operator stream, the operator name itself. And I'm going to just delete this $hip expression and dot. I'm just keeping the base name $OS, this operator name itself, which means if I were to just rename this, and right now if I were to see what this expression is evaluating, just middle mouse button onto that parameter. If I click, and here as you can see it's saying that file cache 1, and if I can middle mouse button again, now I can see what the expression is, and by pressing the middle mouse button I can see the evaluation of the expression. It says file cache 1. That is the name of the node itself. And if I were to rename this, let's say if I were to rename this to smoke, and here you can see this name has been changed also, which means we are grabbing the name from our node itself. That's what the $OS expression is. I can delete this expression and I can manually type the name that I like to store. I'm going to just say smoke underscores sim, and now I am just manually typing my name in here. And onto the base folder, we need to define the location where we want to store our this simulation data. So I'm going to just pick up the location. Let's click on it, and in here you can pick up your location where you want to store. You can pick up your location. I'm going to just create a new folder in here. Let's click on it, and I'm going to call this one our sim, and let hit accept. And I'm creating a sim folder in my this location and hit accept. And right now its name is not correct. Let's go back, and in here we have the sim folder. Let's dive inside and hit accept again, and now we see the correct location $hip and sim. And in here we are going to create this smoke sim. So, and at the front of this we have the file extension. Right now we are using the .bgo.sc. The BGO file is the Houdini native file format. For example, for importing the models, we have the OBJ file format, and we also have FBX, we also have Alembic. And same way, BGO.sc is a Houdini native file format. I can change this to VDB if I want to store my caches as a VDB type, or I can change this to BGO.sc, which means the Houdini native file format, and you should always use the .bgo.sc. The .sc mean that the compression. So BGO is a native file format, and .sc, which mean that we are using the compressed version of our BGO to space our file cache size. So let's use this BGO.sc, and now in here we have the sequence. And here as you can see, we are using the frame range, and our simulation option has been checked on. So whenever you are working with simulation, writing your simulation cache, make sure to keep this option enabled. And right now we are using our entire frame range, our display bar frame range, to write our simulation data. And if you want to limit your frame range, your writing frame range, you can just either adjust your play bar range, and I can adjust this by coming over here. And here as you can see, we have these two values. We have 240 here and 240 here. The first value, it will control the zooming. If I were to lower this value down, let's say I'm going to change this to 50, what that will do, it will just zoom our play bar to 50 frame. And here as you can see, we are starting with 1 and ending with 50. But our entire frame range is 240, which means I can just adjust this slider, and that is just the zooming. I can also control the zooming by clicking this slider, and here as you can see, as I am zooming, I am also adjusting this value. And if you want to adjust your range, your overall display bar range, you need to adjust this second parameter. In here I can say I want to write my 50 frame only, so I can just type 50 in here, and here as you can see, we have our 50 frame range. Our entire range is just on 250, and in here if you take a look, our the start and end range has been also been changed to 50. I can change this to, let's say, 70 frame, and you will see that this range is going to be changed also. Let's click this, and here as you can see, we have this range 1 and 70. So it is getting the information from our play bar. What I can do, if I want to manually add this our range, I can just right click on this parameter and just delete the channel. And because right now if I click on it, here you can see we are using an expression $f_end, which means the frame end. Right now we are using this expression to get our information. I'm going to just right click to delete the expression, click on this delete channel, and that will just delete the expression, which means I can independently our simulation range. Let's say I want to render only 50 frame. So no matter if I were to change this back to 240, you see we are just using the 50 frame. And now I just need to press save to Trisk option to write out our caches. So let's click on this save to Trisk option, and by clicking this you will see down here, and here we have this window, and in here we are caching our simulation data into our disk, and right now it's going very fast. And I think because we are working with a very low resolution of our volume, and maybe let's keep caching out this simulation, and when this simulation cache is going to be done, I can just click on this load from Trisk option to load our caches back, and you will see that when this cache has been done, this file cache node will automatically going to check this option on, which means that we are not going to calculate our simulation up here, but we are going to use our caches to load our simulation data back into our this Houdini session. All done, and here as you can see we have this option right here, and here we are getting this icon, this Trisk icon. It means that our caches has been present in our hard drive and load from disk option has been enabled. And if I were to disable this, or this icon has been gone, indicating that we are not loading our caches from disk, but we are calculating our entire simulation in here. And if I were to enable this, and this icon has been enabled, saying that we are not calculating information. And if I were to view my out render, and I can scrub, and here you can see I can easily scrub, and I do not have this blue bar, which means that we are not calculating. We have calculated all of our information and written out our caches, which means I no longer need to connect this. If I want to, I can just delete this, and I can go in here and I can independently load my caches because they are written in my hard drive. And if I were to middle mouse button, and here as you can see this particular frame is using 100 megabytes, so we have this frame 100 megabyte, and I can change this to maybe let's say frame number 50, and let's middle mouse button, and here as you can see we are using the 226 megabyte of this frame is 226 megabyte. Okay, that is the cache size now, which means I can go into the LOPNet, and here as you can see our new has been imported, new simulation, which means I can scrub and onto the SOP import, because we are referencing our this out null, all of these changes upstream is going to be also updated, and that is the benefit of using the null, which means if I were to change this input, let's say if I were to add the sphere in here and connect this into the out, and now you should see that this sphere is going to be imported in LOPNet. Let's go into the LOPNet, and here as you can see we have this sphere, and that is because this SOP import is referencing our out null node. So that is the benefit of using these nulls. I'm going to just delete this and connect this in here because I want to import my smoke into my LOPNet. Let's dive inside the LOPNet in here, and now we are ready to create the materials and render our smoke simulation.